Thank you for joining us for the IEEE Computer Society Standards webinar series, brought to you by the Standards Activities Board. With over 225 standards that transform the way we live, work, and communicate, the IEEE Computer Society sets the standard for design automation, simulation, testing technologies, Ethernet and Wi-Fi, quality assurance processes, systems architecture, DevOps, and more. Standards deliver best practice processes for developing market-ready interoperating systems, products, and services. You can have an impact by joining one of the over 200 IEEE Computer Society Standards working groups. Participating in one of the working groups grants you access to information that reduces risks, increases proficiency, and shapes the future of the industry. Help determine what's next in computing technology. Learn more about our standard working groups at computer.org/standards.
Hello, everyone, and thank you for joining us today, and welcome to today's webinar from our Standards Activities Board series. In today's presentation, Deep Learning-Based Assessment for Virtual Experiences by Dr. Sang-Hoon Lee. My name is Scott Levine, and I'm the Membership Manager here at the IEEE Computer Society. Before we get started, I'd like to address some housekeeping items. This webinar is being recorded, and you can ask any questions in the Q&A box you see on your screen. Dr. Lee will answer as many questions as he can following his presentation. If possible, please reference the slide your question refers to. You will receive a copy of the slides in the recorded webinar in an email tomorrow. The recently published standard for deep learning-based assessment of visual experience based on human factors, P3333.1.3, is just one of the many standards founded by IEEE. Keep up with our ongoing calls for presentations and get involved with the Standards Activities Board. The IEEE Computer Society is a global community where you can learn about this standard and discover more. As part of this network, you have the opportunity to connect with professionals from all over the world. Expand your knowledge with the Computer Society Digital Library, which features over 90,000 papers and articles highlighting the latest in deep learning research. Furthermore, you can grow with your other professionals through various events such as technical committees, conferences, and chapters. Information will be shared with you after the webinar, and you can always learn more at computer.org. Circling back to today's presentation, a user's quality of experience measurement for virtual display technologies is an important issue, but at the same time, it is subjective and challenging. Thus, the need for deep learning-based models to assess visual experiences based on human factors is inevitable. In this webinar, we will introduce a recently published IEEE standard for the deep learning-based assessment for visual experience based on human factors. We will discuss the standard and some of the works that are based on it. As mentioned, joining us today is Dr. Sang-Hoon Lee. Dr. Lee received a bachelor's in science from Yonsei University in South Korea, a master's degree from Cates in South Korea, and a PhD degree from the University of Texas, Austin. From 1991 to 1996, he was with Korea Telecom, and from 1999 to 2002, he was with Lucent Technologies in New Jersey. In 2003, he joined the Department of Electrical Engineering at Yonsei University as a faculty member, where he is currently a full-time professor. His current research interests include image and video processing, computer vision, and graphics. Dr. Lee has held numerous volunteer roles within IEEE and the IEEE Computer Society. He has held various editor roles with the Journal of Communications and Network, IEEE Transactions on Image Processing, IEEE Single Processing Letters. He returned as a senior area editor for Single Processing Letters in 2018 and still holds that role today. At the beginning of the year, he also began serving as an associate editor of IEEE Transactions on Media. He was also the general chair of the 2013 IEEE Image, Video, and Multidimensional Single Processing Workshop, and has been involved with the technical community for both image, video, and multidimensional single processing, as well as multimedia single processing. Thank you, Dr. Lee, for being here today, and I'll give the floor to you to get us started.
Thank you, Scott, for introducing me. And it's very great opportunity to present our standard through the webinar. I appreciate IEEE Standard organization giving me a chance to introduce our standard. And today, let me talk about overview our standard, and then also the history and side story and collaboration and so on and so forth. So, yeah. Okay. Before we share our opinions from the IEEE SA Standard Association Standard Board by Law 5.2.1.6 at the Rector's Symposia, seminars, or education courses on individual presenting information on IEEE standards, shall make it clear that his or her view should be considered the personal view of that individual rather than the formal position of IEEE. Okay, this is our outline, and let me go over first introduction. And before our working group P333.1.3, we have several issues and events. And so I'm going to talk about the side story before we launching our standard 1.3. And after we approve our PER and we develop our working group standard. And so I'm going to introduce how can we develop our standard work through the collaboration with other members. And so, and I also go over and work in progress, and then I talk about what is the future plan for extension of this standard. This is the outline. Okay. This, as Scott mentioned about my career, and so I am full professor in Yonsei University. Actually, I got my PhD from the University of Texas at Austin. My advisor was Alan C. Bovick, and he's, I think he's one of the most famous academic persons in signal processing area in terms, on the topic of visual quality assessment. And he got a lot of awards, and not only academic awards, but also other society. He got a lot of award. And I got PhD from under him. My topic was the image and video quality assessment. And that is the basic motivation, keep my research on the topic. And also that is one of the great force to build up IEEE working group P333.1. Actually, 3333 means that in this working group, we originally we are going to deal with the three-dimensional image and quality assessment and visual assessment for the next generation, not only 2D, but we would like to extend our standard to the 3-dimensional video quality assessment. That is the basic motivation. So I was chair of this working group, and then that is a type of history behind this standard. Okay, so currently, the metaverse is now very hot issues. So in our laboratory, we are working together to mainly next generation media processing, such as augmented reality and virtual reality. We want to make a bridge from the image video processing to the application of next generation issues, such as metaverse is nowadays is a very hot topic. In order to make such a good research foundation, right? We build up this multi-camera studio in our school, and where we capture the humans using the multi-camera. The number of cameras is over 100, and so we can capture the humans in the 3-dimensional, such as and so this visual information transfer to the graphic information in terms of mesh and point cloud and something like that. So we are going to try to do research image video processing to the computer graphics, so we can make a bridge between these two fields, utilizing artificial intelligence technology, AI technology. That is what we are doing. And so as I mentioned before, before we build up 1.3, right? And so the standard was started from 1.1, right? And 1.1, and the original title was the quality of experience and visual comfort assessment of 3-dimensional contents based on psychophysical studies. Actually, I made an effort to build up this standard 2011, and the first standard we approved March 26, 2015, right? And so maybe 4 years. We took 4 years to finalize the first standard. Okay, so main participate in the first stage of this standard. All the companies joined the standard, but eventually we switch to the individual membership based. So a lot of academic people, mainly from the Korea, France, Taiwan, China, and England, and they UK, they make collaboration. We made a collaboration with them and finalized the standard. Okay, so and the second standard is 1.2, and so which is mainly for the perceptual quality assessment of 3D and ultra high definition contents, and we got approved from IEEE in 2017, right? And so mainly the perceptual, quality assessment on the 3D and the UHD contents was important. So that is a second standard. And after that, we extend them to development of 1.3. And so here is the overview of 1.3. It is the main focusing on human factors for the visual experience, the working group. And 1.3 as this standard has been approved in the February 2022. It's maybe 2 months ago, right? And so mainly currently the total members in our working group is 80 from the 19 countries. And so, but the main university is, there are main universities, Shanghai University in China and Kingston University in UK, and then Nantes University in France and Roma University in Italy. And there are several major universities from around the world. And so we have a mutual collaboration with them. And so let me go over that one. And this is the overview of PER over 1.3. And then the main scope is developing deep learning-based metrics of content analysis and the QoE assessment for the visual contents. So if we wear the head-mount display and enjoy game, you can get a lot of visual experience. So in our working group, we want to quantize and evaluate the visual experience when we enjoying such applications. So that's the main purpose of our working group. Okay, so this is overview, the contents of our standard. So in our standard document, and we have a quality assessment of visual contents and cybersickness assessment of visual contents, and then database of immersive contents. So this is the contents of our standard. And in order to assessment of visual experience, and we made an effort to build up a database. This is one of example, and we build up 360-degree the VR contents, and for given the VR contents, we change the compression ratio. So and then how much visual effect to the human eye, we measure such a visual distortion when you wear the head-mounted display. So that's the one of the things. And also, when you wear the head-mount display and watch the video contents, so human eye may focusing on certain object very carefully, right? Which is called the saliency. So in this standard, which object should be focusing on when you're watching the 360-degree visual contents? So this saliency prediction, one of the topics in our standard. So this is one of the example to the how much effect according to the saliency. Our visual attention can be changed according to the salient object in here. So this is a background, right? On the background, there are a lot of different type of motion, circular motion and roll motion. And on top of this complicated visual contents, we have the salient objects, right? If we have a salient object, human eye mainly focusing on this salient object, so we feel less visual discomfort since we're focusing on this salient object, right? So this is the demo. Okay, so you can see left-hand side. Okay, so left-hand side there is no salient object, but right-hand side we have our objects. So human eye may focusing on this object more, so human eye feel less visual discomfort. Okay. So also, when you have these 3D objects, how much quality we can observe from this 3D object here. So we measure the quality and saliency for given these 3D objects. So this is a timeline. Actually, we request per in 2017 and approval per at the end of that year, and we finalized our standard in the February this year. So actually, we have a long time for finalize the standard. I would like to say the major issue was a database. We made a huge time to build up database. That was a very difficult one to making our standard. So for the mutual collaboration, we visit, our member, the university of our members. Here is the visiting to the Kingston University for the 27th meeting, and also the professor is Maria Martini, and she is a chair of WANDA for now, and we have a very close collaboration with each other. And also, I was a visiting scholar at Shanghai University, and we have a 28th working group, group meeting before COVID situation, right? And also, I work for the Signal Processing Society in Asia, right? And so I advertise 1.3 to the Signal Processing Society member in Asia. Okay, so this is also the launch, and I host the launch and then advertised 1.3. And so also, I am currently editor-in-chief of this APSIPA newsletter. And APSIPA is stand for the Asia Pacific Signal Processing Information and Processing Group. And so, and also through this group, and I also advertised 1.3 as well. And also, the academic work in our working group is very unique in terms of academic. So as a result, we submit a paper to the QMAX. The QMAX is stand for Quality of Multimedia Experience. In this conference, we got some award and Best Student Paper Award. So that is one of pioneer work in this area. So the paper deal with virtual reality sickness predictor. Okay, so at the conference, I asked Maria Martini she is a collaborator in our working group, and I asked her to be a chair. Wonderful. She accepted my suggest, and so she become a chair. Wonderful, in the topic of live field image. So this is a camera array. Using this camera array, we can capture the image. Then we can get this live field image. And so this one is a type of a three-dimensional image capturing and using the application of live field image. And so this is the introduce wonderful, and Maria Martini is working group chair. She has almost finished the first version of draft for the sponge ballet process. Okay, so every year, even the COVID situation, we have a joint workshop. And so this is a joint workshop with the Shanghai University and Nanyang University, and also this is a type of joint research lab workshop, and Shanghai Nanyang University and Monash University Australia and National Taiwan Normal University, right? So we have also mutual collaboration and share our academic result with each other. And this is one of big international symposium done by last year. And we invited 4 keynote speakers. First is that Alan Sibovic. He was my former advisor. Second one is Ionis from the Facebook, and Howley. He was professor in Berkeley, and he is now a thin screen company. And then we also invite a panel discussion, and we talk about the metaverse quality of experience in the international symposium. This is a work in progress, and we are mainly focusing on the virtual reality. And so when we're wearing the head-mount display, we have several visual effects, such as presence, sickness, and we have also different emotional experience as well. So mainly the VR sickness was the different symptom, right? So the parents doesn't allow the kid to wear the head-mount display a long time. So we analyzed the contents, how much VR sickness may have when their children watch this 3D game, right? And then they may feel such a VR sickness. So we want to measure how much, VR sickness we have when we watch the video game. And so this is a VR presence. So when you're wearing the head-mount display, then we also feel much more presence. So, and then we measure the relationship between the presence and the visual discomfort and something like that. So this is mainly from the computer graphics, and then also computer vision stuff as well. And so, as I mentioned before, VR database, we took a lot of time to build up this VR database. And then, when the people wear this head-mount display, we ask them how much presence he's enjoy when he can feel when he enjoy the 3D contents. So we get the subjective score from this watcher, and they just grade excellent, good, fair, poor, bad when they watch this video contents. So we can measure how much presence he has and how much visual discomfort he has, and then when he watched this VR contents. So this is one of the example. I brought this scene to introduce that for the VR database. So we make a scenario and then make this content according to some scenario, and then build up these contents and then provide these contents to the viewer, right? User, and then user, after watch these contents, they evaluate how much visual discomfort and how much visual presence they have. So let me introduce the content. Yeah, this is, the contents we made to measure the visual discomfort, right? So actually, this one is actually graphic contents. So we spent, more than 2 years to update these contents and then to do subjective test. That's the reason why our standard work is so long. Okay, so let me go over what's next. And so actually, we now we migrate some visual, computer image processing to the computer vision, and now we are migrating to the computer graphics. So nowadays, the metaverse platform will be popular, and a lot of different type of XR glasses are coming out, and also, the avatar is a different story. So this avatar looks like a human. It's not. It is quite. It's not quite graphic type of a person. It looks like a real human. So we are going to build up this avatar and put him and put her into the metaverse platform, and this avatar, generate their motion in the avatar platform using the AI technology. So that type of technology development has been widespread out nowadays, and also the people watch their content while wearing this head-mounted display and talk to the avatar in the real time. So the user can feel more realistic world and using this metaverse platform. So nowadays, technology much more development in this world. So our standard should do development to cover such application. Okay, so in my view, one of the major factor is to create the avatar and then animate the avatar to do some similar behavior, similar talking style, similar feeling. So when we're wearing the head-mount display, then we can talk with the avatar, but it's not it's not fake. It's just like a human. So that is what we are shooting for at this nowadays. So in order to capture the realistic avatar, so we build up this type of studio. Actually, the Google and Microsoft, Facebook, and they also build this type of multi-camera studio. So we are going to make a competition with them to how much realistic avatar should be generated based on this technology. That is important things. So when you created 3D humans, actually from the multiple cameras, and in order to build up the 3D object, 3D avatar, there are a lot of noise from the hair, from the wrinkle of the cloth, right? From the surface of face, there are a lot of noise, right? So maybe how much, how much humans sensitive to this noise, and how can we erase, remove such a noise to make a realistic human? That's one of the biggest issues in this field. So we are going to do some quality assessment to quantify the outstanding performance of this removing noise. And so that should be one of the important topics in the next generation standard. And this is one of the result in our using this camera system. As you can see here, the input is only RGB data, right? From this input data, we can reconstruct it 3D human face, right? So if you take a look at this face, it looks like real human. So actually, we need measure the quality, right, of this 3D face compared to this input image, right? So this type of working, we should make a standard, right? This is just the static 3D face. This is something like 3D face animation. It's not just the steady one. It's that they have some. We can make some animation. For the animation, we can have a mark on the face, right? So eventually, even if we don't put the mark on the face, we are going to generate some 3D face animation. How much this this avatar looks like a real human while they talking with each other. So that type of things we are going to review. Actually, the metaverse nowadays is a very hot topics. In Korea, we have a major platform company, Naver. They build up the metaverse platform Jefeto, and also Facebook. They also build up some metaverse platform, and so a lot of major company in U.S. and they develop this type of metaverse platform, but we also make some contribution to which core technology should be used for this making avatar and making the 3D contents and so on and so forth. And so that should be a very important one next generation. Okay. Okay, so this is the end of my talk. So we have a Q&A from the audience. If you have some question, please put the question on the Q&A box, and then I'm trying to do my best to answer the questions. Okay. Okay, so I got the several questions from the audience.
Yeah, Sang-hoon.
Okay.
Want me to read you the questions?
Mm-hmm. Okay.
All right.
Yeah.
So the first question we have is from Kyle, and he wants to know, what is a saliency object?
Okay. Saliency objects means that, yeah, that's a very nice question. So 16. Let's move to the video 16.
Here, let me jump to that slide for you, okay? And
you
can start.
Thank you. 16. Could you move the slide 16, please? Okay, here is an example of saliency objects, okay? So in this case, I mean, I ask the people, I mean, user, which one are you looking for when you watch this video? Then maybe according to the user, somebody look at this area and somebody look at this area, and because in this video, we don't have so much saliency objects. But in the right-hand side, if I ask the user, where are you looking for? Where are you looking at? And they most likely people, I'm looking at this red ball, right? So this red ball becomes salience objects. Salience objects means that when the people watching the video and the user spontaneously focusing on certain object or certain region, we call that object and that region as a salience object and salience region. Yeah, that's the definition of a salience object and salience region. And you know, the VR, AR application, this salience region and salience object are very important because that is a point-to-point application, VR and AR. However, you know, the Netflix, they provide just a video, right? It's a type of broadcasting, right? However, in the VR, AR, metaverse application, each user select their view and their objects using the mouse, using the head-mount display. So in the metaverse application, this salience region and salience objects should be importantly we deal with this salience object and salience region very carefully. Okay.
All right. Excellent. Our next question comes in from Edith. They actually say, thank you for the great presentation. But do you foresee issues of identity theft or imposters in the metaverse? And what would prevent that? Embedded characteristics, or would it be impossible to prevent?
Oh, that's a very tough question. You know, in order to create, this is, there are two types of security issue in the metaverse. Actually, I'm not familiar with the security area. I mean, that is not my scope. I would like to say just unauthorized avatar, maybe he or she appear in the cyberspace domain, right? And so maybe in such case, right, it is quite difficult to identify such an unauthorized avatar is a real, authorized one or unauthorized one. So in order to figure it out, that one, we need to share the feature, common feature among the user. So each user have the feature, have the feature information of the avatar, and then each user recognize such an avatar is authorized one or unauthorized one. So maybe in order to do that, we need to share some of the feature and some of the identity feature before we join the metaverse. So that should be possible, I think.
All right, excellent. I don't see any more questions, so we'll give everyone another minute or so to see if there's any last-minute questions they want to submit. Dr. Lee, is there a way, if people wanted to join the working group, is there a way they would, how would they do that? Is there a site they should go to? Should they reach out to you directly?
So how can they join our working group? Mm-hmm. Okay, so we follow the rule of IEEE Standard. If they want to join our working group, send an email to me. Then I share our link to them. If they join the working group meeting more than two times, then he or she become our working group member. So please send me an email. Then I'm going to share the link with them. Then if they participate in the working group meeting, then he or she became a member. So according to the rule of our standard. Okay, so Scott, we have another question from audience.
Yeah, looks like one more came in. How was the motion sickness correlated with presence, and how large was the sample size?
Oh, yeah, that's a very nice question. Okay, so let's move to the...
What slide was that?
Let me see. Just a second. Okay. So there is a correlation between the presence and sickness. I cannot, it's too small. Actually, it's too small, and there is a slide, the graph to demonstrate the sickness and presence. Maybe, okay, so, okay, let me, just a second. yeah, it's the way. Let me talk about let me give an answer of that question. If we feel more presence, right, we need to feel more discomfort. So whenever we have a camera movement, right, if we have more motion, human feel much more presence compared to the steady state, right? In such case, human feel additional visual discomfort. But if we have a severe motion, right, then human doesn't want to enjoy the presence. So if we feel much discomfort, right, the human cannot enjoy the presence. So in order to enjoy the presence, it is good way to maintain certain visual discomfort, right? If visual discomfort is over certain threshold, human cannot enjoy the presence anymore. So there is some trade-off between the presence and then discomfort. Okay, so that's our result, and so and other things is that how large was the sample size? If I can ask, sample size, we build up the sample size. Actually, we made all the contents unity, and so the unity. We build up all the contents using the Unity software tool, and so in the Unity, right, we can render we can make the rendered view over the 360 degree. So according to the Unity, they provide, good quality good quality of the good quality is more than the 1K. Up to the 4K. That is how can we get from the Unity software. Okay, so the important thing is that making scenario. So we actually, I just demonstrate very shortly about the database. You can see here, right? Number 36. Scott, could you pop up the number 36? Yeah, actually, in order to make a database, the most important thing is that making a scenario. So each scene is changed according to the motion, according to the text, according to the light and something like that. So we change the motion and change the text and change the lightings. And so based on this combination, we also generate motion. So we build up 100 VR scenes and then provide, make a user experience different type of scene. So if we have a roll motion, the human much more has much more discomfort. If texture is more, then human feel much more discomfort and something like that. So according to each parameter, we measure how much visual discomfort each user has. So that type of scenario is very important. Okay.
All right, excellent. Paul asked, how is the standard being used in the industry?
Yeah. Nowadays, we cannot plug in this visual discomfort assessment metric in the AI algorithm at this moment, but our career, we have some regulation of visual safety, right? So we can make this standard to make some regulation of making contents. So if the contents provider, they provide us this 360-degree VR content, we can make evaluate how much visual discomfort these contents provide to us. So we can make some regulation and guideline. This contents is doesn't recommend to users because the visual discomfort is over certain threshold and something like that. So we can use our tool for the guideline of the safety issue in the VR AR, right? And so that is our current status. However, if we move to 1.5 for the next standard, we can evaluate how much the 3D object looks like real in terms of the metric, right? So that's the next standard. But here we just measure the perceptual factor, right, for the VR contents. That's at this moment. That's current stage. Okay.
All right. Excellent. It looks like that's the end of the questions. Thank you, everyone, for submitting such great and really thoughtful questions. So before we wrap up, we just wanted to quickly note our upcoming webinar schedule. The next webinar from the Standards Activities webinar series will be a panel from the Online Gaming Standards Working Group on May 25th, also at 9 a.m. Eastern. The IEEE Computer Society will be putting on 3 additional webinars over the month of April. There'll be 2 from the Build Your Career webinar series. The first one will be 2 days from now on April 7th, focusing on the 5 skills needed to thrive in the workplace. And the other will be on emotional intelligence. Our distinguished lecturer in our webinar series will have a presentation on cybersecurity and critical infrastructure on April 28th. You'll be able to register for all these webinars using the link you'll receive in tomorrow's email with the slides and the recording of the webinar. Again, I would like to thank all of you for attending and Dr. Lee for sharing his knowledge with us today. Thank you again and have a great rest of your day.
Thank you, Scott, and thank you all of the attendees, and thank you for your listening my presentation. Thank you.